Today you will learn how to solve quadratic and polynomial equations by factoring. So we're just going to review what you did in Algebra 2 when you solved quadratics by factoring first. So notice if we have our steps here. The first thing we want to do is we want to make sure our equation is equal to 0. So if we look at A, we want to make sure that it equals 0. So we're going to add 6 to both sides of our equation. X squared plus 5x plus 6 equals 0. The second step for us to do is to factor, and it's no different than what we were doing before. I'm going to take the front times the back, so we have 1 times 6 equals 6. And we know we have 1 and 6, and 2 and 3 is our pairs. We'll set up our empty parentheses, and we know to get x squared, that's x times x. So now I'm going to ask myself which pair adds to give me 5. And remember, I know we're going to have the same sign because the last number is a plus 6. So that means the signs have to be the same because when you redistribute, you want to have a positive number. So we know we're going to use positive 2 and positive 3. And it doesn't matter where you place those because the leading coefficient or the number with the x squared is 1. So that's our second step. Our third step is to use zero product property. So that just means we set each factored piece or each factored expression equal to 0. So x plus 2 equals 0 and x plus 3 equals 0. And then it's like you solve the two little baby equations. X equals negative 2 and x equals negative 3. And that's it. The other thing that is useful to know that if you look at our degree of this equation, it's a 2. So that tells our brains we should have 2 solutions, and we do. Now let's look at B. So the first thing we're going to ask ourselves, does the expression equal 0? And in this case, it already does equal 0, so we can move to step 2, which is to factor. Now, notice this time there's only 2 terms, and there's not a third term or a constant. So if there's only 2 terms, I'm going to ask myself, is there maybe a greatest common factor or a number in which both pieces of the equation have in common? And in this case, they both have a 3 and an x. So we'll factor that out. And remember, it's like 3x squared divided by 3x, which is x. Negative 6x divided by 3x is negative 2. Okay, so there's our factored form. Now we just set each of those factored pieces equal to 0 and solve for x. Now when we divide by 3, we know 0 divided by 3 is just 0. And when we add 2, we have x equals 2. And then again, remember our mental check. We have a degree of 2. We have 2 solutions, so we're good. If we look at the third problem, notice it does not equal 0, so the first thing we'll do is we'll subtract the x, and I'm going to put the minus x in between the 3x squared and the negative 2, so it is in our standard form. So 3x squared minus x minus 2 equals 0. And now we're going to factor it just like we did before. We'll take the front times the back. So 3 times negative 2 is negative 6. And we'll have 1 and 6 and 2 and 3. We'll set up our empty parentheses. We know what times what equals 3x squared. Well, we'll have a 3x and an x. Now we have to ask ourselves which pair, when we add together, we get negative 1. And hopefully you recognize that if we have positive 2 and negative 3, we're good there. Now, this is the tricky part. Because we have a 3x in one of the binomials, we know the factor that is divisible by 3 is this negative 3. So I'm thinking in my brain, 3x times what number equals negative 3x? Okay, hopefully you're saying, okay, minus 1, because 3x times negative 1 equals 3x, negative 3x. And then the other one is the other factor. I want this to equal 2x so that when I add like terms, we get that negative 1. Okay, so now we just set each of our factored pieces equal to 0. and we solve for x. So subtract 2 and then divide by 3. So x will equal negative 2/3. And over here, x equals 1. Now take a minute and try the example you tries. For example, you try A, hopefully you recognize to subtract the 8x, and then notice that 4x is the greatest common factor. When you factor and solve, you do get x equals 0 and x equals 2. For the middle one, when you subtract the 15, you have x squared minus 2x minus 15 equals 0. Hopefully you recognize that factors to x minus 5x plus 3, therefore x equals 5 and negative 3. The tricky one here was letter C. So notice that you have 2x squared plus 5x minus 3 equals 0. So you're going to take the front factor minus the back factor, so the 2 times the negative 3 to get the negative 6. Your factors of 6 are 1 and 6 and 2 and 3. Now because this last sign is a negative, that tells your brain you want opposite signs when you factor, because a negative times a positive is a negative. So you'll use negative 1 and 6. And hopefully when you do your thing, you notice that 2x minus 1 times x plus 3 is the correct factorization. So x equals 1/2 and x equals negative 3. Okay, so now we're going to look at some more type of examples we'll see. So just like we did in the previous slide, we're going to follow the same exact steps. Now I want you to think of this as like x squared plus 0x minus 100. So if I list my factors of 100, notice we have 1 and 100, 2 and 50, 5 and 20, and we have 10 and 10. So which pair is going to add to give me the middle 0? Well, hopefully you recognize it's positive 10 and negative 10. So when we set up our parentheses, we'll have our x and our x to get the x squared, and we just insert the plus 10 and the minus 10. And now we're ready just to set each of those factored pieces equal to 0. And we have x equals negative 10 and x equals positive 10. The end. If we look at letter B, notice there's only 2 terms, but before when we had like x squared minus 100, those 2 numbers were actually perfect squares. And that factorization that we did earlier is actually what we refer to as the difference of squares. We don't have that this time, but notice something we do have. What do we know about 45 and 5? Well, you can take out a 5. What do you know about x cubed and x? Well, there's a greatest common factor of x. So we're going to factor out the greatest common factor first, and we know 5x cubed divided by 5x is x squared, and negative 45x divided by 5x is negative 9. And notice we have a similar situation that we had with x squared minus 100. We know that x squared is a perfect square, and we know that 9 is a perfect square. So we're thinking to ourselves, factors of 9 that add to give me 0. Well, 3 and 3. We can say x plus 3 and x minus 3 equals 0, right? If I list my factors of 9, I have 1 and 9 and 3 and 3. Well, positive 3 and a negative 3 add to give me 0 because there's no middle term. Okay, so all that's left for us to do is to set each factored piece equal to 0. We do get x equals 0, x equals 3, negative 3, it's positive, and x equals positive 3. And remember, if we look at our biggest exponent, it's 3, and that means we should have 3 solutions, and we do. So if we look at our third example, do we have a similar situation? Is there maybe a greatest common factor? Well, we know 2 and 162 are even numbers, which means they're both divisible by 2, and we can factor that 2 out. So x to the 4th, and 2 into 162 is negative 81. Now, same kind of situation. Notice we have a perfect square and a perfect square. So we can factor very similarly to how we did the previous 2 examples. So we know we'll have 2. the square root of x to the fourth is x squared, and the square root of 81 is 9. But are we done factoring? And hopefully you recognize that we have already technically factored x squared minus 9. We factored that in the previous example. So we know we'll have x plus 3 and x minus 3. However, the x squared plus 9 doesn't factor into a real solution. It actually ends up being a complex solution. So the 2 is irrelevant because I know 0 divided by 2 is 0. So we set x plus 3 equal to 0, x minus 3 equal to 0, and x squared plus 9 equal to 0. Well, x equals negative 3, x equals 3, so we have those two for sure. And when we solve for the other, the x squared equals negative 9, and then remember to undo the squared, we square root. X equals plus minus 3i. Remember, anytime you solve by square root, you have to have that plus minus. Anytime you have a negative under the radical, you have to put an I in your answer. And then that's it. You did it. I want you to take a minute and try the 3 example U-tries. Okay, so hopefully for A, you found positive and negative 12 for your solutions. For letter B, 0 and positive and negative 2. Now, the one that was kind of tricky was this letter C. So hopefully you recognize the greatest common factor was 5x squared. And the result, 4x squared minus 9, is actually 2 perfect squares. So we can factor that as 2x plus 3 and 2x minus 3. That is where we get these solutions, negative 3 halves and positive 3 halves. For 5x squared equals 0, it's technically x equals plus or minus 0, but 0 doesn't have a sign. But it still counts as a double solution because it has this 2 here. And that's all you have to do. So the last example is to solve a polynomial. So we've only talked about quadratic equations, something you would have done in Algebra 2. So what we're going to do to solve this function by factoring is we are going to group similar terms and then factor out the greatest common factor. So the first thing I notice is there's 4 terms. Let's try putting parentheses around the first 2 terms and the back 2 terms. Now I'm going to ask myself, what does the first 2 terms have in common? Well, they have an x squared. So I'm going to factor that out. We know 2x cubed divided by x squared is 2x. And 3x squared divided by x squared is plus 3. Now we're going to look at the back 2. What does negative 8x and negative 12 have in common? Hopefully you recognize they both have a factor of negative 4. And we know negative 8x divided by negative 4 is 2x, and negative 12 divided by negative 4 is positive 3. Now, hopefully we start to see that technically you have 2 products. Now, is there a greatest common factor between those 2? Well, they should have a 2x plus 3 in common. Now, if these values don't match, then you have a mistake or error in your grouping or your greatest common factor. So because those guys match, it's like we can factor them out. And then if I take out the 2x plus 3, notice there's an x squared left and a minus 4. And then we just continue factoring. So we'll have 2x plus 3, and we know x squared minus 4 is x plus 2 and x minus 2. And now we set each of those factored pieces equal to 0. So notice we have x equals negative 3 halves, x equals negative 2, and x equals positive 2. And we know we're okay because our largest exponent is a 3, and we have 3 solutions. Let's take a look at B and try that one. So again, the first thing we'll do is we'll put parentheses around the first 2 and the back 2. Notice in the first 2 we have a 4x squared in common. We know 4x cubed divided by 4x squared is x, and negative 12x squared divided by 4x is negative 3. In the back 2, for negative 9x and 27, remember I want it to match x minus 3. So if the 9x is negative, I want to try and take out a negative 9, because it's going to change both signs in those parentheses. We know negative 9x divided by negative 9 is positive x, and 27 divided by negative 9 is negative 3. Notice these guys match, so we can factor those guys out. So x minus 3 times 4x squared minus 9. Now, we know 4x squared and 9 are perfect squares, and there's a subtraction sign between them. So we can factor it to x minus 3 times 2x plus 3 times 2x minus 3. And now we just set each of those factored pieces equal to 0. So x equals 3, x equals negative 3 halves, and x equals positive 3 halves. The end. Take a second and try the example you tried. Hopefully you find that x is equal to negative 1 and positive and negative 2. And we know our solution is okay because our biggest exponent is 3, and we have 3 solutions. Yay, time to practice. The end.